In this video, I'll be talking about and demonstrating Newton's 3 laws of motion. The first law states that objects in motion will stay in motion, and objects at rest will stay at rest, unless another force, usually a push or a pull, changes that. In the next part of the video, I use a stuffed panda bear, a skateboard, and a small seat that my brother made for me to demonstrate the first law of motion. You can see that when the skateboard and the bear are pushed forward, the bear eventually falls off when the skateboard is pulled back, and it stays at the last point that the skateboard reached before it started moving backwards. That is because the bear is not attached to the skateboard. In this part, I put a little seat belt on the bear, as you can see, and the bear stays attached to the skateboard as it moves back. That's because a force is changing the direction of motion. The same thing happens when you wear a seat belt in a car. Newton's second law of motion tells us that the mass, or amount of stuff, in an object affects how much force it takes to change the object's speed and direction. This is known as its acceleration. Mass is also related to weight, so you can kind of think of it as how heavier things usually are harder to push and get moving than it is to push lighter things at the same speed. I tried to demonstrate this by having my little brothers sit on a skateboard and pushing them with about the same amount of force and seeing which one of them moved faster. If I push them with the same amount of force, my brother, who is smaller or has less mass, should accelerate more. When you see the gray shirt, that is my brother that weighs more or has more mass. I recorded these clips in slow motion so that it would be easier for you to read the bathroom scale. Normally, we don't measure force in pounds, but we're working with what we got at home. Now, Parker is much lighter than Holden, so when I push him with about the same force, he moves and accelerates quite a bit faster. And you'll be able to tell because the extra boring silences before he hits the door are much shorter. Newton's third law states that every action, or force, has an equal and opposite reaction. So, in the little doodle, we have two people pushing against each other. The person in purple has rollerblades on. So, when they push against the other person's also pushing back against them, even if they're not trying to. And the person on the skates moves backwards. The opposite reaction is that the person who's just standing there also gets pushed back, but because they're on skates, they might just feel like they're getting pushed backwards and they might even fall. Holden helped me demonstrate this by standing on the skateboard and pushing against the wall. Holden pushes against the wall, and as confusing as it might sound, the wall also pushes back against Holden. Holden is just pushing against the wall, so we know that the wall has to push back against him because Holden moves backwards on the skates. Because the wall is attached to the house and sturdy, the wall itself doesn't really move, but Holden moves backwards. In this case, the action is Holden pushing against the wall, and the reaction is the wall pushing Holden backwards. Also, I'm really sorry that I apparently don't know how to hold a camera straight. Please enjoy this blooper of my parents' cat getting in the middle of my demonstration.